In this session, I will show you how to use Syntasa data and AI platform to build a zero trust analytics solution. Before we jump into the demo, let's briefly talk about zero trust security framework and behavioral analytics. The gist of zero trust is that every request is untrusted until the security policy engine turns it into a verified request. As the adoption of zero trust framework continues to gain traction, the initial focus has been on the plumbing that enables the organizations to enforce their policies. While vendors offer robust policy enforcement capabilities, they leave the job of defining the security policy to the host organization. Typical examples of these rule policies goes something like authenticated users can only connect to the system if their devices are known and their IP addresses are whitelisted. Effective policy definition is critical to success of any zero trust implementation. Ongoing monitoring and analytics is required to continuously improve policy definitions. So as we mentioned, effective policy definition is critical, and a typical deployment will include a SIEM component for security information and event management, which can collect and monitor zero trust framework events. One of the best ways to enhance the effectiveness of your zero trust solution is to use behavioral analytics. Zero trust analytics with Syntasa would look something like this. This is a demo of Syntasa's capability to create zero trust pipelines for AI and ML within the Syntasa platform. So you have data coming from different systems. For example, in this case, we have data coming from Chrome events, a Palo Alto network tool that generates events, Microsoft Office events, and Google Workspace events. It's important to note that you can get started with zero trust even before you have all of your components in place, and gathering and collecting data from some of these systems are not that complicated, and I'll show you how we can do it in a Syntasa platform. So all the data is merged, and then once the data is merged, it's possible to apply the different AI apps for detecting user patterns, journey analytics, if you will, or pattern of life analysis, as some people call it, doing anomaly detections and creating risk scores. And then the outcome of these models can be used for activation back to the policy engine, as we showed earlier, or just for the reporting. So let's go jump into the demo here. What you see here is a 30,000 feet view of the apps. This is our app flow diagram. We're within the Syntasa user interface, and all of these tiles here, each of these represent an app, and in an app flow diagram you can represent an end-to-end solution. So you can see that, for example, in this case, the Chrome events connects to a connection to pull the data in, as we showed in the previous diagram. And this is the representation of that diagram within the application. So, for example, we can go into one of these applications, and you can see what's inside the application. Each app has a development sandbox and a production section. We are in the production section, and you can see it's a DAG. It's an app, it's a workflow that shows red circles for processes, green circles for processes, and squares for objects, mostly data sets, but it could also be other objects like ML models. In this case, the data coming from Google Workspace event has tokens. It gives you information about Google Meet, data studio logs, workspace audit logs, and login attempts. And then we go through a series of transformations to normalize the data and then consolidate it in a normalized way in our workspace event. So you have now one data set, so you can kind of see as the data comes in how it looks like. You can look at the data sets, and then as we go through the transformation, we end up with transform. So going back to the app flow diagram, now that you've seen how these are worked and we built like the merging, I won't go into this in more detail. In another session, we can cover the details of setting this up. I want to briefly show you some outputs of this. So let's first start with our user behavior or user patterns analysis here. Here you can see the different users. The usernames are kind of encrypted or anonymized so that like the people that are using this don't need to know the exact users. It's certainly possible to make it available to authorized users as well. So what you see is users here, devices, and then in this user behavior pattern analysis, what we're interested in, what are the steps that users take as they go through their journey? So in this case, we can see the step 1, and of the population that we're analyzing, majority of the users basically start their journeys here with a SSL access. So these are people outside of the network. And as I said, you don't have to have full implementation of your zero trust. So in this case, people are getting into a VPN to connect to the network. And this tool allows you to get a much better understanding of the behavior of your users as you move towards a full implementation of zero trust. And you can see, for example, the next one is like a lot of people use SharePoint, a lot of people use Microsoft Exchange, tokens from Office, Data Studio. So, they're like different things. Now, let's just look at it. And you can see, like, for example, the pattern of the usage. Weekends are lower. You can see step 2 of the journey, step 3 of the journey. You can see what are the provider steps. Like, majority of people spend their time in one system. Some people go from Office to Google Workspace. So this is at the provider level. So generally, your population is either like Google users or Microsoft users. And then you can see the journeys as well. So you can see, for example, some people going from Office to Exchange, back to SharePoint and things like that. So let's just quickly click on a few users to get a better feel. So this particular user is a heavy Exchange, SharePoint, and Teams user. You can see how they start their journeys during this analysis period and what are their subsequent steps. Now, if you look at another user, this user here is also a Microsoft SharePoint user, but the other user was a more heavier Exchange user. This is a more SharePoint and Teams user. So another user, let's look at another user that their behavior is totally different. This user uses a lot of Data Studio. They start with Data Studio as their first step, and we basically remove repeated steps. So you can see that their second step, there's nothing else for their second step, meaning these are probably report developers that are spending a lot of time within the Data Studio report platform, or just report users, which may not actually touch anything else. So you now got a feel for how the user behavior looks like. This is another view of that. So what we can look at here is for a period of time, we can see sessions, duration, all of the activities. So we can see like the users again. Here in this case, each concentric circle represents a step in the journey. So for example, we can see that here, these are, if I just scroll down a little bit, you can see that these are like SharePoint's starting point, as you can see in the box that's being generated. And as I go up here, you can kind of see maybe how people are having different usages and what their journeys look like. And we can click and filter on all of these. I won't have enough time to do that, but it's an interactive tool that you can, for example, say, if you look at this here, you can say, okay, show me all the journeys that are starting at the center of this here. So this being the network SSL step that we talked about, and you can see from here people might continue with getting a workspace token in Google and continue their journey maybe to do a workspace login. Okay, so we got a little bit of feel for that. So you now saw different people, their behavior, and maybe I can basically go back to another view here. So we saw different users, we saw how their behaviors are different. Now what you can do is you can map all their behavior to a two-dimensional space, doing a dimensionality reduction technique that's very helpful for visual clustering. And each dot here represents a user. So if I come here, these are like the users that are doing the workspace token SSL. We just looked at some of them. You can see there's a good chunk of users in this area. If I come here, here are some of the Exchange logins, Data Studio. Here you might have like Data Studio logins. So if I go here, you can see another group of people. These are just Data Studio users. Here's another group of people. These are your Microsoft Exchange users. This is interesting. This is just basically resources that use Google Meets. These are external users. These are users that do a lot of SSL access. So this clustering technique allows us to see where the developers are, maybe where the finance people are. And this is just based on this information. As we enhance and add more metadata, this kind of clustering begins to give you a feel of who is doing what at what point. And then what is this useful for? It's useful for building a behavioral based baseball card, if you will. So for a given user, you can have information. Where do they log in? They're coming in here, in this case from Romania. What are their last actions? What are like the support actions that they've had? And if we go down, you can see like what applications they've used, what activities they've had. But more importantly, you can also see the results of the models that have been, AI models that have been applied. So you know this user has a very low propensity for asset downloads. So if all of a sudden you see a lot of asset downloads, you can immediately alert that this is not normal behavior for this user. Or for example, asset creation or remote connect propensity is high. So you won't get worried if this is a remote connect. Alternatively, somebody else could be very low propensity to do remote connect. So if they do remote connect, you want to be on the alert. So this gives you a good idea of like how you can use Syntasa data and AI platform to implement a use case. And as I said, basically, Syntasa data and AI platform is a tool for implementing a variety of use cases, not just this use case. We've successfully done a number of other use cases in terms of propensity scoring, natural language processing, computer vision. So this is just one example. It runs in any of the major clouds, and it also runs in a Kubernetes, Rancher Kubernetes cluster. It's a full Kubernetes application. It uses the cloud native resources, and basically it host manages security, scalability, governance and compliance. And within Syntasa, we leverage open source technologies, so it's extensible. As new technologies emerge, we are constantly considering adding them as needed. It offers a Jupyter-based notebook plus a visual low-no-code workflow. I showed you the visual workflow. I can show you the Jupyter-based notebook in another session. And it is ideal for collaboration between data engineers, data scientists, and analysts. And what's really unique about it is most other tools collaboration is siloed within the different groups. But in this case, it does not really require collaboration with people that are all coders. So through the use of code-based tools like the Jupyter Notebook and our code processes and our low and no code features, we can support expertise propagations from coders to non-coders so that the community can benefit across the board if there are good models developed, for example, in the case that I showed you for behavioral analytics in the zero trust application. That's all that I have to show you, and thank you.